Let me talk about natural log, right? Since natural log and E are just two elements of a pair, right? Natural log is the inverse function of natural exponential function of E raised to the power of x. So what is an inverse function? What are inverse functions? Well, when we say a function is an inverse function, when this function is symmetrical about y equal to x with another function, okay? With another function. Okay? So let me repeat, okay? Inverse functions. Okay? When we say one function is inverse function of another, that means these two functions, they're what? Symmetrical. They're symmetrical about what? Y equal to x. Okay, y equal to x, that line. Okay. Here, first, let me give you the definition of natural log function. Okay, natural log function. So let's say m is equal to e. So here is natural. Excuse me. Here we use e as base, right? We raise it to power of p. Okay. Then we rearrange the function a little bit, turning it into a question. We say, well, if we want to raise power of base e and make that raised power of base e equal to n, so the final product is n. So I want to raise e to some power, and the power I don't know. And once I raise the power, well, this term is equal to n. Then my question is, what power should it raise to? Well, it turns out to be p if we know this equation. So it reverses the mathematical operation here. Let's raise base e to power p, and we know e and we know p, and we want to know what is the final product. The final product is n. So n is what we want to know. But now we reverse the question. Okay, we say, well, we know the base is e, and we know the final product is n. But what is the power that I should raise e to so that the final answer is n? Well, if we know the first part, then we know that answer is p. So that is definition of natural logarithm or natural log function. Okay, so here we use base e because logarithm can use different kinds of bases. It does not have to be e. It could be equal to the base could be 10. That's another pretty commonly used option, or other numbers, right? Next, I want to talk about some basic properties of logarithm function. Okay? First, the logarithm function turns what? Turns multiplication into addition, like the exponent of base e. Right? So here we have log of parenthesis a multiplied by b. What is that equal to? Well, it is equal to log of a plus log of b. Okay? And if we want to have a division here, log of a over b here. And it is equivalent of what? Log of a minus log of b. And here I can give you examples, right? Log of 2 multiplied by 3, what is that equal to according to this product rule? Okay, it is equal to what? Log of 2 plus log of 3. Right? And here, let's say log of 2 over 3. What is that equal to? Equal to log of 2 minus log of 3. Okay. Okay. And the last but not least is this power rule, right? So let's say we have this number within the natural logarithm function, right? Log of a raised to the power of b. What we can do? Well, we can move this power in front of logarithm. Okay. Give you an example. Let's say log of 2 raised to the power of 3. What is that equal to? Well, it is equal to what? Move 3 in front of the log function. Equal to 3 multiply by log of 2. Multiply by log of 2. Okay. And here we can have a quick look of natural log function, graphically. And for natural log function, okay, note that, well, here, x has to be a positive number. X has to be a positive number. Otherwise, this function is invalid, does not work, okay? And if we take a log of any positive number, then the log of x can be any number on the real line. It could be positive, it could be negative. It could be positive and negative. And one interesting fact, kind of similarly, is that when x is equal to 1, yeah, as equal to 1, then log function becomes log of 1, right? What is that equal to? That is equal to 0. And this is equivalent of saying e raised to the power of 0 is equal to what? Equal to 1. Equal to 1. Okay.